Rats. Well, I bet by the time that this meeting starts, I can introduce a really cool but honestly kind of basic problem in physics that turns out to be a major unsolved problem in modern theoretical physics. Think of a force. If you thought within the realm of physics and not of Star Wars or anything, then that force can be categorized as one of the following: gravity, electromagnetism or electricity and magnetism, the strong nuclear force, or the weak nuclear force. Physicists call these forces the four fundamental forces of nature. That should be a good enough setup for this question. Among these four fundamental forces, which do you think is the strongest? It's intuitive to say gravity. After all, gravity is the force that collides entire galaxies together and keeps enormous planets revolving around their stars. But take a look at this. This is a paperclip. Pulling down on it is the gravitational force of the entire Earth, nearly 6 septillion kilograms of rock, water, and life as we know it. Its opponent? A magnet. Who wins? Of course, the paperclip goes to the magnet. So gravity's not the strongest fundamental force. The strong nuclear force is actually the strongest force, but pay attention to how the other forces compare to the strong nuclear force in terms of strength. Electromagnetism comes in second, 137 times weaker than the strong nuclear force. The weak nuclear force, a million times weaker. And then there's gravity. Gravity is 6 million billion times weaker than the strong nuclear force. You might have guessed already that we're not all that concerned with which force is the strongest. Rather, we're more interested in why there's such a huge discrepancy in strength between gravity and the other three forces. This is known in theoretical physics as the hierarchy problem. A lot of physicists want to find an answer to the hierarchy problem because knowing why gravity is weak is a giant step towards understanding the true nature of gravity and the true nature of the universe. It seems so intuitive in everyday life, but trying to understand gravity has led to scientific breakthroughs like Newton's law of universal gravitation and Einstein's theory of general relativity. And now, to solve the hierarchy problem, the next breakthrough might come in the form of string theory, a popular candidate as a solution. String theory says that actually gravity's not weak. It's just as strong as the other three forces. We just don't feel its full strength because gravity exists in higher spatial dimensions beyond our 3D world of length, width, and height. It's sort of like how measuring the volume of a cow in 2D would produce really tiny, confusing results, but once you go into 3D, you're like, oh look, it's a cow, and things make a lot more sense. Assume that gravity is a cow. So there you have it. Now you know about the fundamental forces, the hierarchy problem, and why gravity might be a cow. Until next time. Dang it!